Some of you may have wondered who the real-life equivalent of Ellie, the wonderful heroine of that film, is. And she's about to speak to you now. Carolyn Porco was the consultant for the film. She is the character on which the character of Ellie was based, and I think you'll see it when she stands up to talk. She's a most distinguished planetary scientist, leading the team of the imaging of the what's it called, Carolyn? The Cassini, I'm so sorry. I blocked on the name Cassini, imaging of the planets, and it's Carolyn and her team who are responsible for sending back these stunning images that we have seen of especially the outer planets. One of my responsibilities at Oxford was to organize an annual Charles Simoni lecture, a very big high-profile lecture in the public understanding of science. And one of the people that I really wanted to get and succeeded in getting to come and lecture in that series was Carolyn Porco. She gave the most magnificent lecture, which people were talking about for ages afterwards. It's a great pleasure to introduce Carolyn, the third speaker in our RDF series of sponsored lectures at this conference. Carolyn Porco.
Thank you very much for that introduction, and thank you for inviting me to this wonderful conference. I see that you're commemorating the legacy of Darwin. And I don't know if anyone has mentioned it to you yet, but this year, 2009, is the year that astronomers, both professional and amateur alike, are commemorating the legacy of Galileo, who 400 years ago this year took the newly invented telescope and for the very first time pointed it upward. And with that simple act, he flung open a window on a new era in humankind's understanding of the cosmos and our place in it. Now, Galileo was no slouch. He not only discovered the phases of Venus with his telescope, noted the craters and the topography of the moon, discovered the moons of Jupiter and the rings of Saturn, but he is also credited with being the father of modern science. And the reason for that is because he was the first to develop and use what we have since called the scientific method. And this is a method, a simple method in which you make a guess as to why something might be the way it is, or a guess as to the way some physical system might work. And then you conduct an experiment to see if your idea is correct. And if it's only partially right, you tweak your idea and you try again. And if it's completely wrong, and this is critical, if it's completely wrong, you discard the idea. Doesn't matter how much you love this idea, doesn't matter how proud you are that you came up with such a phenomenal idea. If it doesn't work, you throw it out. And I can tell you lots of scientists stubbed their toes on this one. Even Einstein stubbed his toe on this one. But that is the way the scientific method is supposed to work. 400 years on, this may all sound very simple and obvious, but at the time it was revolutionary. And no one had gone about the investigation of the natural world in this way before. That is, actually conducting experiments in which you try to mimic some aspect of the natural world, but you do it in a controlled fashion. And you try to come up with a law or a general principle, a mathematical description of the behavior. Galileo's first experiments were focused on very simple things. He worried about motion. He worried about how things move. Why, if you push it, does it keep moving? Why doesn't it suddenly just change its direction? Why doesn't it suddenly accelerate? All these things that to us seem so obvious now, this is where we were in our study of the natural world there, and that's where Galileo focused. But the method that he developed, this formulation of a hypothesis, the testing of the hypothesis by experiments in comparison with the natural world, and the development of a general principle that can be used to predict the outcome of future experiments, was a giant and powerful leap forward in its approach. And I think that the moment that Galileo came up with this idea qualifies as the most subversive moment in the history of humankind, because it was at that moment when we finally began to have the means to verifiably separate truth from falsehood. And from then on, it wasn't what some powerful monarch or some church figure had to say which made it truth or not. Nature herself was the final arbiter. And as you may know, Galileo got himself into a world of trouble with this. He was in trouble with the church because of his views on the architecture of the solar system and the inevitable result from his observations that the Earth and humankind on it were suddenly evicted from the center of the universe. But it's interesting to think about the scientific method as it applies to the existence of God. Because if someone were to give me the task of investigating the existence of God the way I would say investigate the motions of the bodies in the Saturn system, and required me to bring to bear on the matter all the training that I had received about how to prove or disprove an idea, and then required me to write a scientific paper or publication on the subject, I can tell you right now that it would be a paper with no conclusions. There is no physical evidence whatsoever that can be presented or examined to prove God directly that God exists. No one has yet captured God and brought him back to be examined in a scientific laboratory. And of course, it's very difficult to prove that God doesn't exist simply because it's very difficult to prove a negative. And let me give you an example of how this would work. Take the case of my proving that I do or do not have cockroaches in my house. Okay, all I really need to do, if I want to prove to you I have cockroaches in my house, all I need to do is find one cockroach, dead or alive, or maybe even just the droppings of cockroaches, to convince a reasonable person to their satisfaction that I have cockroaches living in my house. But now think about what I'd have to do to prove to you I have no cockroaches living in my house. Okay? I'd have to be able to observe every cubic inch of my house, the floors, the ceilings, the walls, the furniture, the cabinets. Every cubic inch of my house I'd have to examine all at the same time because cockroaches move, right? Simultaneously, I'd have to examine every cubic inch of my house to prove to you that there were no cockroaches living in it. So it's a difficult thing to prove a negative, and so it is with God. Science is agnostic when it comes to the existence of God, and it has to be. You can't apply the scientific method to this question. And so if you were to ask me if I believed in God, since I am a professional scientist, I would want to give you two answers. Okay, in my capacity as a professional scientist, I would be required to be agnostic on the subject, since I couldn't, with scientific certainty, say that there is a God, and I couldn't, with scientific certainty, say that there isn't. But if I were allowed to respond as just a regular non-scientist, and if you allowed me to take the very same indulgences that all other non-scientists are allowed to take, and that is I'm allowed to reject the training I've received as a scientist that taught me, that drilled into my head, not to accept anything as fact that can't be scientifically proven, but instead I'm now allowed to do what many others do and profess. I'm allowed now to profess to know something and to profess to strongly believe it in the complete absence of facts. Okay? People do this all the time. Then I would have to say, now just as a regular schmo, I'm going to have to say that my very strong faith, my very, very strong belief is that there is no God. But on this level, you're not supposed to clap. On this level, okay, on this level now, my belief is perfectly equivalent to religious belief. Okay, we're both doing the same thing. So when a scientist says the charge on an electron is 1.602 times 10 to the minus 19 coulombs, okay, that is not an expression of belief or faith. That is an established fact. It's based on many, many Galileo-type experiments following the format that was established by Galileo 400 years ago. It is not at all equivalent to religious belief. But when a scientist says there is no God, and he's acting in the capacity of a scientist, he's not giving you a scientific conclusion on the subject. He is at that moment expressing a personal belief and opinion. Now, it may be to some that's an opinion that carries more weight because, after all, it's coming from a person who's been trained in examining things using the principles of logic, using induction, using deduction, and so on. And it's coming from a person who's trained to withhold final judgment until all the facts are in. But nonetheless, it can only be an opinion. And in this case, it is, as I said, it's an opinion that could be put on a par with religious belief because both are expressed in the absence of evidence. So I'm going through all this and making this distinction because I think it's important. The battle is not really religion versus science per se. These two things are not so much incompatible as they are just not equivalent and not intersecting. I think the tension lies in the type of thinking and approach that is peculiar to both. One encourages uncritical acceptance of ideas, and the other seriously discourages it. Now, the danger and the concern, I'm sure, to everyone in this room is that uncritical thinking has been and is still extremely prevalent. To be sure, even today in our oh-so-modern world, God and religion are thriving. But I don't think at its heart it's an issue that's an ideological one, because I don't think people think much about it, because I don't think people think much, period. I believe religion has been so resilient because it is a cultural phenomenon. It's a cultural embed, if you will, like ethnicity or language or cultural traditions, like celebrations or food. You know, I eat spaghetti, you eat matzah. And such things are deeply, deeply rooted in people. So telling someone who firmly believes in God, and we know them all, there are relatives, there are, brothers and sisters and mothers and fathers and so on. Telling someone like this who's firmly believed in God since they were a child, because they were raised to believe such and because their family traditions all revolve around the belief of God or the religions that revolve around belief of God, telling such a person that there is no God and that they are foolish to even believe in one is like telling the English that the French are better than they are. Okay? And you can imagine how that might go down in Jersey. So, also keep in mind that scientific thinking is very young. If you want to date it back to Galileo, it's only 400 years old. And if you want to be generous and date it all the way back to the Greeks, well, then it's about 2,500 years old. But religions have been around for tens of thousands of years. Something like 30,000 years ago, they were finding burial sites where bodies were, food and animals and all sorts of, fancy things were buried along with the person because they believed in an afterlife. So religion is very old and science is not. So maybe in light of this, it shouldn't be so discouraging that religions continue and more people have not been won over to critical thinking because it just hasn't been a significant amount of time. And I think that to see significant change, it's going to take a cultural timescale. That is, we will see things change in people's belief and this prevalence of irrational thinking and so on. We may see a major shift, but only on a cultural time scale. So we'll have to wait the same length of time that it takes other cultural elements to change before this particular issue change. Or put another way, religion will fade away on the same time scale over which the English become indistinguishable from the French. Sorry, Richard. So this may all seem hopeless, but the world is getting smaller and technology is accelerating cultural change. And knowledge and information, they spread quicker now than ever before. So it's possible. The infrastructure is in place and it's possible for widespread communications to promote rational thought on a large scale and to erode the irrational underpinnings of religious thinking faster than we could have imagined, let's say 50 years ago. But even for this to happen, the message has to be available, that there is a benefit on a personal scale, on a personal level, on a cultural level, and on a global level, that there is benefit to moving towards reason and moving towards rational thinking. Or put it another way, the content has to be there. So for as long as people could talk, the way that content, that is messages and values and traditions and other cultural elements, the way they got passed around and on to future generations, and the way they became culturally entrenched was through stories. Okay, and here's where I'd like to take perhaps an unexpected turn and discuss one big factor in the way that messages about anything in our culture get out there, and that is through film and by extension television, because that is the medium of choice. People would rather go to the movies or watch television than read a book. And it's patently clear that both TV and the movies have an enormous power to shape public opinion. Anyone with something to sell, from advertisers to politicians, they are smart enough to take singular advantage of this medium. The selection of jurors in highly publicized cases is carefully controlled because of the biases that can be injected by skewed television coverage. The magnitude of natural disasters can be overplayed and underplayed simply by editing. Okay, very simple to do this. In the study of the natural world, scientists distinguish between two types of processes. There is a linear process in which a very small change brings about a very small effect. And it requires a large change to bring about a large effect. Okay, you mix cream into your coffee in the morning. You mix a little bit of cream, the coffee gets a little bit whiter. You mix a lot of cream, it gets a lot whiter. Okay? So a nonlinear process is one in which a very small effect can have a very small change can have a large effect. It's a process that has a built-in amplification to it. So, as an example, the climatic phenomenon known as El Niño is an example of a nonlinear physical process. It's a change of a degree or two in the Pacific equatorial sea surface temperatures that can cause the winds to change their direction at the equator, which then drives a change in the direction of the ocean currents, and that further alters the temperature. So this feedback cycle can therefore amplify a very small temperature difference and cause ultimately changes in the weather patterns all over the globe. You start with something very small and local, you end up with something big and global. It's very nonlinear. Small temperature change off the coast of Peru, and it rains like hell in China. Okay? So it strikes me as I consider the impression that is left on us when we watch TV or go to the movies. And just to make this discussion simpler, I'm going to lump that all in with the rubric of Hollywood. I'm going to call it Hollywood, even though Hollywood isn't oftentimes a monolith, and people within Hollywood, as we heard last night, can think differently from one another. Just to make it easier to talk about, I'm going to call it Hollywood. And it's perfect because Hollywood's just right next door, so maybe they're listening. Okay, but it strikes me as I consider the impression that Hollywood has left on us about science and its practitioners, that both TV and the movies, the small screen and the big screen, serve as great nonlinearities. They're the great amplifiers in modern life. A really successful and popular movie can take a mere idiosyncrasy and make it appear like it's the norm. Okay? Even worse, it can take a lie and, to the unquestioning viewer, make it appear as truthful as the blue of day. An article in the New York Times about 10 years ago reported on a couple of surveys that were done of science-related Hollywood films undertaken by two independent research outfits. And both found overwhelmingly negative depictions of science and technology in the movies, dating all the way back to the 1920s and up to as recently as 1994. As I said, this was about 10 years ago. Common characters and storylines were the evil, mad scientist who's hell-bent on blowing up the world, technology run amok, even from well-meaning but bumbling scientists like Back to the Future or Jurassic Park or Frankenstein. And of course, there's always the ever-popular nerdy but socially misfit scientist who's incapable of making it in the real world. Now, to prove my point, think about how deeply rooted the image of the evil German scientist has become since World War I and II. Okay, for how many years did the mere mention of the word scientist conjure up the image of a rigid Nazi-like man with a German accent? Even my older brother, as it became clear that I was headed for a career in The Scientist got to calling me Wolfgang. I'm not kidding. That was short for Dr. Wolfgang von Porco, I swear. So a handful of German scientists made their way onto our radar screen during the war years. Hollywood uses them for the basis of character development. And for 60 years after, our typical, stereotypical scientist is still a bad guy with a German accent. I call that power. That is incredible power. Okay? Science and its practitioners are seldom honored. They are more often ridiculed and hated and feared. And why? Because it works. It's lucrative. The Frankenstein monster, the disasters wrought by technology. When faced with technologies that rapidly change the order of things, like the release of nuclear energy, which immediately changed the character and consequences of warfare, the development of commercial flight, which profoundly changed life all over the world, or the computer, which replaced many of the functions previously performed by humans, it is not uncommon for people to respond with ambivalence and suspicion and even fear. And above all else, to many, science and technology seem to have replaced humanity and spirituality, which for many is a frightening prospect. So perhaps the evil scientist is nothing more than the necessary personification of that fear. And to see the evil scientist receive his or her comeuppance is soothing to people, because they think, okay, we're safe after all. The bad guy gets it in the end, and we can go back to our safe existence. Now, Hollywood makes use of other themes for sure. There's boy meets girl, there's warfare, there's the murder mystery, and all of these are very lucrative storylines. They're used over and over again. You vary the characters, you change the costume, you change the setting, but the theme is the same from movie to movie. We've been seduced by formulae, and we've accepted it. But I think the Hollywood vision of science has become particularly myopic, and it's found an angle that worked, and it has never in all these years, it doesn't seem to have veered from it. I'm not arguing that monsters and technological disasters and evil scientists don't make good stories. I'm arguing that they're not the only stories. And for all the accolades and the many cases well-deserved that circulate within Hollywood, that celebrate the brilliance of its writers, its directors, and its producers, the content is still woefully lacking in diversity. There is, to my mind, a great opportunity for storytelling in dramatizing the scientific quest for the truth, and it remains unharvested. So here are just a few things that you might consider if you were going to go about making a movie. Science is mystery. Okay, there is great storytelling in the painstaking, methodical gathering of evidence, the assimilation of facts, the 2 steps forward, 1 step backward paradigm of progress towards the ultimate solution, and all the emotional angst, the highs and the lows that carry the detective and the storyline forward. And as Richard pointed out, that eureka moment, that fabulous moment when everything suddenly just makes sense. Okay, this is classic mystery. It's only better in science because it's the truth. And what the movie industry has done for the murder mystery, it can do for science and nature's real mysteries. Here's another angle. Scientist is dramatic hero. That is, the person who dedicates his or her whole life making tremendous sacrifices to find out some simple fundamental truth, however small it might be, about the nature of nature. Okay? And in some cases, only proven in the end to be wrong. Okay? How many here in this room have read the book Longitude? Okay, it's a great book. It's a story about the development of a clock that would work at sea so that people, the boats at sea, captains and so on, could tell where they were in longitude. And without this, it just wreaked havoc on the, ships were constantly being shipwrecked because the sailors didn't know where they were. Finally, this guy Harrison comes along, and I don't know how many years he spent on this, 20, 40 years. It was an incredible story. Finally came up with a clock. And there was great competition. This was a story that had intrigue and deception and competition and frustration and losing and winning, all the classic story elements. It was surprising to me, it was enormously successful as a book, written by Davis Sobel. Another angle is scientist is the ordinary guy, okay? Most scientists are actually, for the most part, ordinary people. They're perhaps a little nerdy. but they fall in love, they have children, they get divorced, they enjoy athletics, and so on. Some of them are even likable. If you're after a story about the life of an ordinary person, a scientist will do just fine. Okay, science is adventure. When the pursuit of the truth entails a mental or a physical challenge and a long, arduous, or even difficult and dangerous journey, there are certainly tales of high adventure to be told here, and I'll say more about that in a minute. And then one of my favorites is the science's allegory. The quest for the truth, in and of itself, is a story that's filled with insights and with lessons. Like the quest for the Holy Grail, it can be noble and dignified, and it signifies a deep and ancient longing in the human soul for fulfillment and connection to something greater. And then finally, science's sociological phenomenon. What do people do, either collectively or as individuals? What do they do, think, or feel when confronted with an irrefutable truth that may be uncomfortable, disquieting, and even frightening, and which overthrows their strongest beliefs? There are many, many examples in history of scientists like Galileo who were persecuted or even executed for enunciating a belief that ran counter to prevailing notions. So let me use Contact as an example. How many people have seen Contact? Okay, so you know it was about the confrontation, the boundary, the fundamental dividing line between the religious approach to belief and the scientific approach to belief. And the main character, who was trained as a scientist and disciplined to withhold belief in the absence of evidence, finds herself in this tremendously ironic position where, bereft of physical evidence, she cannot prove what she knows to be true. And in this sense is identical to her religious companion, Palmer Joss, who firmly believes in God, but cannot prove it. I would say, I know I'm prejudiced in this, but I would say that Contact as a movie worked. It had at its core mystery, the pursuit and defense of the truth, and a riveting eureka moment. It had the dramatic heroine encountering obstacles, meeting with failure and ridicule, and triumphing in the end, even if she is alone in her knowledge of her triumph, which only added poignancy to the story. And it explored the sociological phenomenon surrounding a deeply disturbing discovery. It did not really explore all the intellectual themes that were in the book as much as I would have liked. The book is way better than the movie was, but I think sufficient attention was paid to the main character and her mannerisms, her clothing, her style of speech, and to the other scientific characters to make them believable, and the science facts and fiction were as accurate as could be made. Now, in the interest of full disclosure, I will say it was very hard for me personally to imagine any religious zealot being as sexually effusive as Matthew McConaughey. But you know, all things considered, it was a small sin of miscasting in an otherwise really good film. And you know, who knows? Maybe people of the cloth feel the same way that we do, and they've been terribly miscast all these years, and they'd like to be thought of as sexy as anyone else. So let's give them a break. Anyway, there easily could be more movies like Contact. Hollywood, in my eyes, has an opportunity to educate and inspire, and it should not be squandered. So you might ask, well, why is this even important? To me, it's obvious. We live in a technologically based society, the ever-shrinking computers, the cell phones, the ridiculously small integrated circuits, the multi-button video machines, high-resolution TV, and all this, they arrive at our doorstep with discomforting speed every year. And our lives have been made staggeringly different because of all this with each passing year. And who are the real masters of these ceremonies? Well, they're the scientists, the poor slobs who are stuck, no doubt, in the basement of some building, because they always stick the scientists in the basement. Okay, it's those guys who discovered the principles on which all these beneficial developments are built. And it's their painstaking work to understand and utilize the universal laws that govern everything around us that made all this possible. That we have come so far in the enterprise of understanding nature, far enough to pry open the nucleus of the atom, to sail through interplanetary space, to lose ourselves in the internet, and perform medical surgery with laser beams. All of this is cause for great celebration, not fear. And it's time we quit hiding all this under the covers and let these people come out of the shadows into the light of day and take accurate stock of their accomplishments and their failures and make an attempt to understand what they do and why they do it. And Hollywood could play the starring role in creating this new outlook. Thank you. Now, the back effect on the populace of feeding the public a skewed view of the scientist and his or her world is sad to contemplate. We're living in it right now. Just think how many impressionable young individuals who might otherwise have been interested in a life dedicated to scientific pursuit, and they turned away from it because it wasn't cool. Okay? They saw an off-putting perception of it by watching the movies. And how many brilliant minds, which might otherwise have been engaged in breaking new ground in fields such as physics or chemistry, molecular biology, genetics, and on, were turned away because they perceived that scientists are not valued, their work is not valued, their work is not considered noble, but instead it's nerdy, it's uncouth, it's socially unacceptable. It's a very, very sad commentary on the values in our culture when shooting a ball into a basket is more laudable, more praiseworthy, more admirable, and more rewarded than teasing out some fundamental truth about the natural world or finding a cure for AIDS or cancer. There is, in the end, a whole universe of stories that could be told about the benefits that the scientific enterprise has brought to human existence, an enterprise that's built on the application of reason and logic and Galileo's scientific method. And I'm now going to tell you about one of my favorites. The story I want to tell you is a remarkable story about the inhabitants of a small and rocky, ocean-covered little world in orbit around an ordinary star in an ordinary galaxy. And this story goes that these beings, with soaring imagination and laughing at the idea of boundaries and limitations, over time developed the languages of mathematics and science, became skilled technologists, developed mastery over gravity, and eventually flung themselves and their machines into the interplanetary space surrounding them. And they did this merely in response to an innate desire to explore and to learn about their cosmic neighborhood and to secure the future of their progeny and to seek the answers to questions that had vexed them and every generation of their ancestors before them. How is it that their small planet and they living on it came to be? And what is the great cosmic theater in which life on their planet had unfolded? Well, you probably figured it out already, but this is a story about us. And we humans have been interplanetary travelers now for over 50 years. We've been to just about every corner of the solar system. We've been to all the planets, all 8 of them. We've been to the comets. We've landed on asteroids. We even right now have a spacecraft on its way to Pluto. And of course, we have set foot on our own moon 40 years ago this year. And these magnificent journeys, these long, arduous journeys, have in fact rewarded us with insights into the origin of the Earth and its fellow planets, and they have shown us with startling clarity our place in the cosmos. The latest chapter in this story is presently being written at Saturn, which is a rich and complex planetary system, and one of the most promising places we could ever hope to explore in our solar system in search for answers to such big cosmic questions. We had flown by Saturn before in the early 1980s with the Voyager mission, but our investigation of this system began in exquisite detail when the Cassini spacecraft, traveling for 7 years across interplanetary space, glided into orbit around the planet in the summer of 2004, and at that point became the farthest robotic outpost that humanity had ever established around the sun. And since that time, we have been engaged in a major exploratory expedition of this far away and alien wilderness, a place that until just a few years ago we had seen literally only in passing, and now we have taken up residence around and we have come to know intimately. We have discovered a great many things in the 5 years that we've been in orbit around Saturn. We've had the chance to observe processes within the planet's rings that are key to knowing what happened long ago in the formation of our solar system, when it too was a disk of material before the planets formed. We have found that the surface environment of Saturn's largest icy moon, Titan, which is 50% larger than our own moon, is enshrouded in organic haze, is like something out of Jules Verne. We've been able to see down to the surface now with Cassini, and we've found dune fields made probably of organic solids that completely gird the equatorial regions of this body. We know that it rains not liquid water, but it rains compounds similar to paint thinner, and we see seas of these liquid compounds in the polar regions of Titan. And we found geysers shooting from the warm south pole of Saturn's small moon Enceladus that we believe now may be erupting from a subsurface sea of liquid water and organic compounds, or in other words, a subterranean, subsurface zone within this moon in which life, or even perhaps its precursor steps, may be stirring. And it continues. We arrived at Saturn at the height of northern winter, shown here with the shadows of the rings draped on the northern hemisphere. The sun is shining on the southern hemisphere coming from below. This is how thin the rings are when they're seen at dawn. Okay? And a month ago, we observed northern vernal equinox. This is when the sun set on the rings. The shadows of the rings on the planet have slipped down to be just a narrow line, and the rings went dark. And at these low sun angles, it allowed us to detect vertical structures poking up above the rings because of the shadows they cast. And to our great and total shock, we found that in some places in the rings, we have walls of ice rubble that reach 2.5 miles above the plane of the rings, and the rings are only 60 feet thick. Okay, this wall of rubble is 2.5 miles high. Now imagine flying in a spacecraft over the rings, a sheet of debris, 60 feet thick, end to end would slide in nicely between the Earth and the Moon. So the Apollo astronauts flying over the rings between the Earth and the Moon come upon a wall of icy rubble 2.5 miles wide. You might think this was science fiction, only it's not. So for most of the people who are even aware that we are, in fact, at Saturn this very moment, the most memorable of Cassini's returns is an image that will probably be Cassini's greatest legacy because it has such a resounding personal relevance to all of us. And it is an image that we took while far from the planet, in its shadow, looking back as Saturn totally eclipsed the sun. And you can see in this image the main rings illuminated, backlit by the sun. You can see the refracted image of the sun poking out through the atmosphere of Saturn from behind. And you can see this diffuse blue ring, which is in fact the ring that's made from the spray that's coming from the moon Enceladus. And also, as if that all wasn't beautiful enough, across 1 billion miles of interplanetary space, we can spot our own planet Earth nestled in the arms of Saturn's rings. There is a powerful recognition that stirs within us when we see our own gorgeous little blue ocean planet as it would be seen by others in the skies of other worlds. It's a recognition that never fails to move us. And it is here, in this picture, where Darwin meets Galileo. Because it is a picture that's made possible by Galileo's first experiments with gravitation so long ago, and it is a picture that, to me, shouts evolution. I look at this image and I see our ancestors stepping down from the trees and walking upright for the first time onto the African savannas and pausing to look back at the forests from which they came. And I look at this image and I see a species that is positively unyielding in its pursuit of knowledge and brave and fervent in its longing to grasp the meaning and the significance of its own existence. And finally, I see in this image the very best that humanity has to offer. We are perhaps the small and troubled inhabitants of one tiny little planet, but we are also the dreamers and the thinkers and the explorers who took this picture. One world across 1 billion miles of space to another, the extraordinary citizens of planet Earth. Thank you.
Carolyn, I was moved to tears by that scene in Contact that I described at the beginning, and you have moved me close to tears again now with these magnificent pictures and your wonderful poetic language to accompany them. Truly, we have a new and female Carl Sagan in our midst.